So we're still in section 10.1, and today we're going to talk about quadric surfaces. So I want to remind you of a definition that I gave you last time, the traces of a surface. The traces of a surface are its intersections with any planes that are parallel to one of the coordinate axes. Those are the planes that we get with just x equals a number, y equals a number, and z equals a number. So we'll just hop over to GeoGebra and remember what these look like. Okay, so here I have the surface that is given by the equation z equals x to the fourth plus y to the fourth. This is actually not a quadric surface. We're just going to look at this one to remember what traces of a surface are. All right, and the plane that I've got graphed there now is the plane x equals 0. That's actually the yz plane. And I'm going to let that plane move around a little bit. Okay, but it's always parallel to the yz plane. And you can see that dark curve there that is intersecting the surface. Those are traces of this surface. We can also turn on y equals 0, and we can see the curve that it intersects with there. That's another set of traces. We can let this one slice. These look almost exactly like the traces with the x equals a planes. They're just rotated 90 degrees. Then we can also slice parallel to the xy plane with z equals a number. And these look like almost like a cross between a square and a circle, these slices here. All right, so these traces tell us a lot about the surface, even if we don't have GeoGebra graphing the surface right in front of us. Today we're going to talk about quadric surfaces, and quadric surfaces are surfaces whose traces are all conic sections. So like I said, quadric surfaces are surfaces whose traces are all conic sections. So remember our conic sections, we had 4 of them. We had circle, ellipse, parabola, hyperbola. So if you have a surface and no matter which way you slice it, you get one of those 4 conic sections, you have a quadric surface. Here's our first quadric surface, x squared plus y squared over 9 plus z squared over 4 equals 1. And we're asked to find 3 traces of the quadric surface. And we know what this looks like visually. If we had the picture of the surface, we'd just be slicing it with that x equals a, y equals a, z equals a kind of plane. How do we do that numerically or algebraically? Okay, so I want to pick x equals something and slice this surface with it. Well, I can pick any number for x that I would like to. This thing has an infinite number of traces. I'm going to pick x equals 0 because that's the nicest number to plug into an equation. And that's just what we're going to do. You're just going to plug in x equals 0 to see what happens to the equation of the surface when x is equal to 0. So I'm going to plug in 0 squared plus y squared over 9 plus z squared over 4 equals 1. The x term has disappeared, so this is just y squared over 9 plus z squared over 4 equals 1. And that equation should look familiar in its form. It looks like the equation of an ellipse, and it is. It's an ellipse that lives in the yz plane where x is equal to 0. So we can remember that the center of this thing would be at y equals 0, z equals 0, because there's no like parentheses squared giving us a different center. We would know that the y radius, we talked about that word that I made up, it's not a real math word, is 3. And the z radius would be 2. So we would know how to graph this in the yz plane. Okay, so let's just write down some information. This is an ellipse in the yz plane. And let's write down the center. All right, so the x coordinate of the center is at 0 because we plugged in x equals 0 to find this curve. And then the y and z coordinates are 0 because of that part of the equation of the ellipse with the red arrows pointing to it. Again, there would be parentheses giving us a different center if that was the case. So 0, 0, 0. All right, so we need 2 more traces. Again, 0 is always the easiest number to plug in. So let's plug in y equals 0 and z equals 0. All right, so plugging in y equals 0, I'll get x squared. The y term will disappear with the 0, and I'll get z squared over 4 equals 1. It's another equation of an ellipse. Okay, this one, I can think of that as being x squared over 1. This one just has x's and z's. This lives in the xz plane, and it's got an x radius of 1 and a z radius of 2. So this is also an ellipse in the xz plane. And again, the center We know because we plugged in y equals 0 that the y coordinate is going to be 0. And the x and z coordinates are also 0. We can see that from the equation of the ellipse. All right, third trace, let's plug in z equals 0. So that'll leave me with x squared plus y squared over 9. The z term gets 0, so it gets wiped out, equals 1. This is another ellipse. This one is in the xy plane. And again, the center is going to be the same thing. I plugged in z equals 0 to get this ellipse in the first place. So that coordinate is 0. And looking at the equation, x squared and y squared, that looks like an ellipse with a center at 0, 0. Okay, so let's go graph these three curves and see if we can use it to picture what this surface must actually look like. Okay, so our first trace that we calculated was when we plugged in x equals 0 and we got an ellipse in the YZ plane. So I think that's this one. Yeah, so there's our ellipse in the YZ plane. And we talked about how it had a y radius of 3 and a z radius of 2, and that's exactly what that looks like. All right, then we plugged in y equals 0 and we got another ellipse in the xz plane. Right, that was x squared plus z squared over 4 equals 1. And again, an x radius of 1 and a z radius of 2. And then our third curve, our third trace that we got was an ellipse in the xy plane. And that had an x radius of 1 and a y radius of 3. Okay. And when you're looking at those three traces, again, you can kind of imagine what this surface is going to look like. All right, so if I turn the surface on, GeoGebra probably graphed exactly what you were expecting that surface to look like. Okay. So traces are important. They kind of let us know about the behavior of the surface without having to look at the graph. Okay, here's our next quadric surface. We're going to find three traces of this, and we're going to take the same stab at it that we did earlier. Let's plug in x equals 0, y equals 0, and z equals 0. So this would be an excellent time to pause the video and see if you get the same traces that I do. So let's plug in x equals 0. When I plug in x equals 0, the x term disappears, and I'm just left with negative y squared over 9 plus z squared over 4 equals 1. All right, so that almost looks like the equation of an ellipse, but one of them is a negative term. And remember, that's what gave us the graph of a hyperbola. So this is a hyperbola. We only have y and z variables, so it's in the yz plane. Okay, and again, we can tell things about this graph. We know that it opens in the z direction, up and down, because the z term is positive and the y term is negative. We could draw that little box that goes 3 tick marks in the y direction and 2 in the z direction, and we could graph this by hand. We know how to do that. We're going to let Desmos do that for us in a minute. All right, so let's move on to our next trace. Let's plug in y equals 0. Again, my y term is going to disappear. And at first glance, this kind of looks like the equation of an ellipse. I guess technically it is an ellipse. It's a special ellipse. The numbers underneath x squared and z squared are the same number. So we have like an x radius of 2 and a z radius of 2. This is actually a circle. And this is a little bit easier to see if you multiply both sides of this equation by 4. Then you're going to get x squared plus z squared equals 4. So this is actually a circle of radius 2 in the xz plane. All right, let's find our last trace, z equals 0. So I'm going to get x squared over 4 minus y squared over 9. The z term disappears because I'm plugging in 0 equals 1. And I'm back to another hyperbola because that y term is negative. This is going to be in the xy plane. Okay, so this is a hyperbola in the xy plane. Okay, so let's head over to GeoGebra and see if these three traces are sufficient for us to imagine what this surface looks like. Our first trace that we got was by plugging in x equals 0, and we found that that was a hyperbola in the YZ plane. And there it is. And just like we expected, it opens up in the Z direction. Can't really see the box, but we get the idea. And then we plugged in y equals 0. Y equals 0 gave us a circle in the XZ plane. So there's that circle of radius 2 that's living in the XZ plane. And then when we plugged in z equals 0, we got a hyperbola living on the floor in the XY plane. Right, we can see that one going there. And this one might be kind of a little bit harder to visualize than the last one. I was pretty sure I knew what this looked like looking at the traces on the last surface. This one we might need a little bit more information. So I'm going to go back to the equation and I'm going to calculate 2 extra traces and see if it helps me to visualize this surface a little better. So when you're asked to find traces of a surface, you get to pick any plane in the world that you want to plug into. X equals a number, Y equals a number, Z equals a number. And we've used up all of the 0 planes that we can do, x equals 0, y equals 0, z equals 0. So now I'm just going to plug in another number. And I'm going to plug in something for y. So you notice when we plugged in y equals 0, that negative term disappeared and we stopped getting hyperbolas. All right, so I'm going to go with that y term. I'm going to plug in something for y. And again, I can plug anything that I want to in for y. But for example, like if I decided to plug in y equals 1, I'm going to get this fraction, 1/9. So I'm going to try to be smart and pick a number that's not going to give me a fraction. So I could plug in y equals 3. I would get 3 squared over 9. All right, so let's do that. Let's plug in y equals 3. So I'm going to get x squared over 4 minus 3 squared over 9 plus z squared over 4 equals 1. 3 squared over 9, that's 9 over 9. That was by design. That was going to give me 1. It's a little bit more work than 0. All right, and let's add the 1 to both sides of the equation so that I can get the x's and z's by themselves. It's going to give me 2 on the right. Usually our conic sections, we like to have 1 over on the right unless it's a circle. And this is going to be another circle just because those x and z numbers are the same. So I'm going to do the same thing I did on the last slide and multiply everybody by a 4. And that cancels out my 4's. I get x squared plus z squared equals 8. Right, and this is a circle. Its radius is not something pretty. I have to take the square root of 8. Okay, so the radius is square root of 8 or 2 root 2. Okay, so this is another circle in the xz plane with radius square root of 8 or 2 root 2. Okay, and it's worth noting the center of this circle. Again, from the equation, we can tell that the x coordinate and the z coordinate are both 0, right? X squared plus z squared doesn't give you that set of parentheses that moves the center around. All right, but we got that equation by plugging in y equals 3. So the center of this circle is going to be at y equals 3. Okay, so we're going to move out to 3 on the y-axis and plug in and graph this circle there. Before we go back to graph it in GeoGebra, I want to notice that I would have gotten the exact same thing if I had plugged in -3. So if I had plugged in -3, I still would have gotten 9 over 9. I still would have gotten that 1. Okay, so we'd get exactly the same circle as if I had plugged in 3 or -3. Okay, so I'm kind of just going to cheat a little bit and say that if I plugged in y equals 3, I would get the same thing if I plug in y equals -3. We would still get the same exact circle in the xz plane. The radius would still come out to the same thing. And the center this time is going to be at 0, -3, 0. Okay, so it's a nice thing about quadric surfaces. A lot of times they come with squares and we get the same traces for positive and negative values of a variable. All right, so let's go ahead and plot those 2 extra traces we got. We're going to go over to y equals 3 and y equals -3 and graph circles with the square root of 8 for the radius. Okay, so there's the one at 3 and there's the one at -3. All right, and this might help you to visualize the surface a little bit better. We've got these extra circles. Okay, so we get the idea that when we slice it vertically parallel to the XZ plane, we're getting all these circles, and they appear to be getting bigger to match up with those hyperbola traces that we have going in the other two directions. So when I graph the actual surface, we get what we might have been picturing at this point. So when we meet together in class again, I'm going to give you a handout that's going to allow you to predict what these quadric surfaces look like just by looking at their equations.